Okay, bears. Today we are going to dive a little deeper into stoichiometry. We're going to actually start bringing masses into the mix here. And as a reminder, stoichiometry is basically you determining how much stuff you can make in a reaction from some given amount of reactant. So it's actually the real kind of chemistry here. Okay, like we're trying to figure out, hey, if I have this much of something, how much of the other thing can I actually make? So last week we talked about, that's going to bother me if I don't highlight that. Last week we talked about just basic mole-to-mole stoichiometry, and you guys did a project on stoichiometry in real life. So for example, my example was 2 slices of bread and 1 slice of ham gives us 1 ham sandwich. Okay, so to make 2 ham sandwiches, it would take 4 slices of bread and 2 slices of ham. Okay, and all we have to do is look at that equation for that. So our reaction here, making water, okay, this is just a review of our moles. If we want to make water, it takes 2 hydrogen gas molecules, 1 oxygen gas molecule to produce 2 moles of water. Okay, so if we want to make 6 moles of water, for example, we would need 6 moles of hydrogen and 3 moles of oxygen. Okay, so we need half as much of that oxygen. Okay, so based on, so now we know, we've seen that you guys understand what the mole ratio means. Okay, now we can go with our balanced chemical equation, we can go from the mass of one substance, so substance A, okay, we can go to the mass of substance B. Okay, so we could say, how many grams of my product can I make starting with this much of my reactant? Okay, and this all depends on, let me clear these off. This all depends on our mole ratio. And our mole ratio, it just comes from our balanced chemical equation. Okay, so you got to make sure your equation is balanced. All right, so let's get started. Let's dive in. We're going to look. So we're going to start with the mass of one substance. Okay, figure out how many moles of that substance we have. And based off the number of moles of that substance, we can convert to another substance using that mole ratio in our chemical equation. Once we know the moles of substance B, we can multiply it by the mass of substance B to get to the molar mass of substance B, to get to the mass of substance B that can be made by that mass of substance A. Okay, so let's take a look at our first example here. We've got ammonium sulfate, which is this guy, being made by this reaction. Okay, so if we want to make 150 grams of ammonium sulfate, how many grams of ammonia, which is this is ammonia, it's a common name, will we need? Okay, so let's come up with a path. Okay, so we can start with reactants, we can start with products, it doesn't really matter. So we're going to go from grams of ammonium sulfate, grams of NH4 to SO4. Okay, then we're going to go to the moles of NH4 to SO4. And the way we're going to do that is using its molar mass, its MM. Okay? Then we're going to use, now we have moles of ammonium sulfate. Now we can use the ratio of their coefficients. So our mole ratio, this 2 NH3s, right? 2 NH3s for every 1 NH4 to SO4. You can use that mole ratio to get the number of moles of NH3. Now that we know our number of moles of NH3, we can use its molar mass to tell us how many grams of NH3 were required. Okay, so I'm going to run through that again. We're going to start with grams of ammonium sulfate, use its molar mass to help us figure out how many moles we have. Then from its molar mass, I'm going to do a little check mark business here. So from its molar mass, we're going to get to moles of ammonium sulfate. Using our mole ratio, we can switch over from moles of ammonium sulfate to moles of ammonia. Once we have moles of ammonia, we can use its molar mass to give us the number of grams of ammonia. Okay, so let's, so here's some things that you're going to need to know. You're going to need to know the molar mass of ammonium sulfate and the molar mass of ammonia. Okay, excuse me. So you're going to need your periodic table, so if you don't have it, please pause this video and grab it. Okay, so I didn't leave myself a lot of room down here, but I'm going to figure out my molar masses up here, up a little higher. Okay, so I'm going to do that in black. So the molar mass, I'm going to start with the easier one of NH3. Okay, we have one N that has a mass of 14.007, and we have three H's that have a mass of 1.008 each. Okay, so that gets me 14.008 plus 3.024. Nope, 02. Yeah, it's 4. Is it? 02. 3 times 8 is 4. Okay, but that gets me a wrong number, so hold on. I'm just going to put it in my calculator, guys. 3. This is embarrassing. 3.024. Okay. Oh, you know why? Burger, because it's not 14.008. It's 14.007. 17.031. So that's the mass of ammonia. Okay. The mass of ammonium sulfate is going to be a little bit more annoying because we have NH4 with a 2, then SO4. There's a lot of stuff going on here. All right. Excuse me. We have 2 N's because this 2 goes here. We have 8 H's. We have 1 S and we have 4 O's. Okay, so N is 14.007. H is 1.008. S is 32.06. And O is 15.999. All right. So remember, we haven't even started our stoichiometry yet. We are just doing molar masses. So we have 28.014. We have 8.064. We've got 32.06. And we've got 63.996. Okay, so I'm going to talk a little bit about sig figs here. My molar mass for sulfur ends at the hundredths place. So my molar mass for this whole thing has to end at the hundredths place. You can only go as far right as the one that goes the least right. Okay, so we add all these together using our calculator. We get 132.134, which I'm going to round to 132.13. All right, cool. And here's what I'm going to do. I'm going to write the molar masses down here. So the molar mass for this guy is 17.031 grams. And the molar mass for this guy was 132.13 grams. Okay. Let's do this. Okay, so we're going to start with what we're given in the problem. Always start with what you're given. We're starting with 150.00 grams of NH4 to SO4. Okay. Now we want to get rid of grams of that. And, oh, you know what? I flip-flopped these masses. That's the wrong mass there. This is going to be 132.13 grams and 17.031 grams. Okay, so we have to get rid of grams and get moles. So grams is going to go down here. NH4 to SO4. And moles, 1 mole of NH4 to SO4 goes up here. Okay, and that molar mass is 132.13 grams. Okay, so if I was to stop my problem here, which I'm not going to do, my units would be moles of NH4 to SO4. Okay, so we have gone from this step, try that again, burger, this step to this step. Okay, now it's time for that switch over. So we're going to switch over from moles of ammonium sulfate to moles of ammonia. Okay, so I'm going to look at our balanced chemical equation. We get, for every one of these, we started with 2 of those. So, again, for every 1 mole of NH4 to SO4, we used 2 moles of NH3. Where did those numbers come from? That's a great question. Person I invented in my head. Those are the coefficients in my chemical equation. This 2 to 1 ratio. Okay. If I was to stop my problem now, my units would be moles of NH3. But I'm not going to do that. Okay. I'm going to keep on keeping on. All right. Now, I have to get rid of moles of NH3, so it's going to go down on the bottom. 1 mole of NH3 weighs 17.031 grams NH3. This is why we were pretty serious about you labeling everything, because now we're switching over from moles of one thing to moles of another thing. So now moles of ammonia cancels out, and my unit is grams of ammonia. Okay, so put this in your calculator, see what you get. Remind yourselves about the sig fig rules. Okay, this number here, this had 5. This has 5. The mole ratio does not count, so our answer can actually have 5 sig figs. Okay, so what I got as an answer, and I hope you did too, is 38.669 grams of NH3. Okay, so we just solved one stoichiometry problem. All right, cool. Let's go to the next one. Let's try again. All right, if we are starting with 18.5 grams of sulfuric acid, how many grams of ammonium sulfate are made? All right, well, I like this problem, and here's the reason why I like this problem. I already figured out one of those molar masses. Okay, sulfuric acid, I don't know its molar mass yet, but I'm going to figure it out. Okay, so let's figure out our plan. We are starting with grams, and here's my chemical equation right here. Grams of H2SO4. We're going to use its molar mass, okay, to determine how many moles of H2SO4 we have. Once we know how many moles of H2SO4 we have, we can determine how many moles of NH4 to SO4 are made using our mole ratio. And just for fun, let's take a look at it. Okay, I'm going to erase what's here right now. Look at that. That's a 1-to-1 mole ratio. If there's no coefficient, it's a 1-to-1 ratio. Okay, so that's just a 1-to-1. Okay, and from moles of ammonium sulfate, I can figure out my grams of ammonium sulfate. Okay, using its molar mass. And I already know that that guy's molar mass is 132.13 grams. I figured that out before. Okay, in a previous problem. The one just before this. Okay, so before I get started with this, I need to get the molar mass of sulfuric acid. But that's not too bad. So I'm going to do it over here in the corner. I've got 2 H's. Okay, it's H2SO4. 2 H's, 1 S, 4 O's. Each H is 1.008. S is 32.06. Oxygen is 15.999. Okay, so 2.016, 32.06, and 63.996. Okay, we're going to come into that situation again where we have to round to the hundredths place because of our sulfur. Okay, so when we add this up and round it to the hundredths place, it's going to become 98.07 grams. Okay, so that's my molar mass of sulfuric acid. So I'm going to write that here, 98.07 grams. Okadokers. So we are starting, we're going to write what we start with here, 18.015 grams of H2SO4. We're going to get rid of grams and get moles by using our molar mass. So in 1 mole of H2SO4, there are 98.07 grams of H2SO4. Okay, we just figured that out. So check, check. We're at moles now. Can't stop, won't stop though. Okay, so grams of sulfuric acid cancels out. Okay. Now we're going to use our mole ratio of sulfuric acid to ammonium sulfate to switch over from one to the other. So it's a 1-to-1 ratio. So moles of sulfuric acid needs to go on the bottom to go away. 1 mole of H2SO4 gives us 1 mole of NH4 2SO4. Okay, so now I've done my mole ratio part, and now I have moles of ammonium sulfate. So I'm going to cross off moles of H2SO4 because that is not there anymore. Okay, so now we're going to get rid of moles of ammonium sulfate. So for every 1 mole of NH4 2SO4, we get 132.13 grams of NH4 2SO4. See how I'm labeling everything? I want you to do that, okay? It's very important. Okay, so what are we left with here? We are left with 18.015 divided by 98.07. You do not need to put times 1 divided by 1 into your calculator. You can do that if you want. If it makes you feel better, you can do that. And then times 132.13. Okay, these are all at the same step of PEMDAS, so it doesn't matter if you do multiply, then divide, or multiply across, and then divide, divide, divide. I personally like to go across, go one step at a time, and do whatever step it's telling me to do. Okay, sig fig check. This is 5, this has 4, this has 5, so I can only have 4 in my answer. Excuse me. Oh, not 18.015. Burger, come on, it's 8. I just got so excited about the mass of water that it's actually 18.5. Okay, so that only has 3 sig figs. So when you put this in the calculator, you get 20.883, repeating. So the answer then is 20.9 grams of NH4 to SO4. Okay. Hopefully we're feeling a little bit more comfortable with mole calculations. Okay, we're going to do just a few more together. And then you're going to do some practice. All right, so we have methane. This is methane. CH4. And oxygen, producing carbon dioxide and water. And if you're thinking to yourself, well, Mrs. Berger, that looks a lot like a combustion reaction, you are absolutely right. Okay, so we are starting with grams of CH4, and we want to get 2 grams of carbon dioxide. So I'm going to put grams of CO2 all the way over here. Well, I'm going to go from grams of methane to moles of methane using my molar mass. From moles of methane, I'm going to go to moles of CO2 using my mole ratio, my MR. And from moles of carbon dioxide to grams of carbon dioxide using my molar mass. Okay. So I know I'm going to need the molar masses of CH4 and carbon dioxide. So I have, for CH4, I'm going to do it now. CH4, I've got 1 C, 4 H's. It's 12.011 grams. 4 H's, 1.008 grams. 12.011 plus 4.032. 16.043. Okay, so I'm going to put that here. Its molar mass is 16.043. And then for CO2, we have 1 C times 12.011 and 2 O's times 15.999. Okay. Add them up. 44.009. Okay, so we'll put that here, 44.009er. I'm going to write grams because, I need to have units. All right, so we have 100 with a dot after it. That means 3 sig figs, boys and girls. 100 grams of CH4, methane gas. And now we want to go to moles of methane gas. So for every 1 mole of CH4, it is 16.031. It is not that. 16.043 grams of CH4. Okay, and now I have to use my mole ratio. Well, looky here, my friends. That's a 1, and there's a 1. Look at that. That's super fun. So now for every 1 mole of CH4, I also get 1 mole of CO2. Okay, so now I've gone from grams to moles of something else. And now for every 1 mole of CO2, you get 44.009 grams of CO2. Okay, so again, sig fig check. This number here is going to limit you. It's got 3 sig figs. Remember, our mole ratio does not count for sig figs. Okay, so we get 3 sig figs. And so our answer, we're going to do 100 divided by 16.043. Okay, so that takes care of this step, this step. I don't need to do this step. Then multiply by 44.009. That gets me 274.3 whatever. But I have to round it to 3 sig figs, so it's 274 grams of methane. Nope, carbon dioxide. Because that's my only unit that's left. I should have crossed them off. Grams of methane, grams of methane, moles of methane, moles of methane, moles of carbon dioxide, moles of carbon dioxide. Sweet. Let's do it again. Okay. How many grams of carbon dioxide can be collected if 41.9 grams of oxygen gas? Ooh, O2. That's a Brinkelhoff, okay? That's one of those diatomic molecules, oxygen gas, okay? Oxygen gas is, we have the mass of carbon dioxide, the molar mass. It's 44.009. O2 is simply 2 times 15.999, which is 31.998. Awesome. Guess what? Our calculations of molar mass are done. Let's go. Let's get this bread. Okay. So we're starting with 41.9 grams of O2. So we have to go from grams of O2 to moles of O2 next. So in 1 mole of O2, there are 31.998 grams of O2. Okay. Now let's take a look at my mole ratio. Okay, my mole ratio, so I'm getting rid of grams of oxygen. Okay, my next step is to switch over from moles of oxygen. So I'm going to go moles of oxygen to moles of carbon dioxide. Okay. Well, I've got, for every 2 moles of oxygen, I get 1 mole of carbon dioxide. So for every 2 moles of oxygen, I get 1 mole of carbon dioxide. Okay. And now, so I'm going to get rid of moles of O2, moles of O2. And now for every 1 mole of carbon dioxide, I get its molar mass in grams, so that's 44.009 grams of CO2. Where did I get that number from? I calculated it previously for the other problem. Okay, sig fig check. I've got 3 here, and I bet you that's my lowest number. Yepperoni it is. Okay, you're going to put this in your calculator. 41.9 divided by 31.998. Okay, get your answer. Divide it by 2. And then multiply your answer by 44.009. Okay, these are all at the same step of PEMDAS, so that's why I'm saying just do it all from left to right so you don't lose anything. Okay, your answer is 28.8 grams of carbon dioxide. Isn't that fabulous? I think it's fabulous. All right, last example. Oh no, it's words. No. It's okay. I got you. All right. Copper 2 chloride. Well, I know copper 2 chloride looks like this. CuCl2. Reacts with sodium nitrate. Well, I know that sodium's a +1, nitrate is a -1. To produce copper 2 nitrate. So CuNO3, 2. And sodium chloride. Whoa, I know what you're thinking to yourself. You're thinking, hey self, that looks a lot like a double replacement. And you would be right, okay? Is it balanced? It is not balanced, okay? Not at all. I've got 2 chlorines here. I've got 1 chlorine here, okay? It's not looking good, all right? But let's see what we got going on. If I put a 2 here, ooh, tuna. Get it? 2Na, tuna. Haha. All right, that gets me 2 sodium chlorides. So it gets me 2 sodiums on my product side. So I have to put a 2 here in front of sodium nitrate. That balances me out because I also needed 2 of these nitrates. Okay, cool beans. All right, last problem. If I have 20 grams of copper 2 chloride, what mass of sodium chloride is formed? So I need the mass of copper 2 chloride, and I also need the mass of sodium chloride. And just because we've been calculating molar masses this whole video, I don't feel the need to calculate them out for you right now. So I'm just going to tell them to you. So the molar mass of CuCl2 is 134.452 grams. And the molar mass of NaCl is 58.443 grams. Okay, that should help. Okay, so we're going to go from mass of CuCl2 to moles of CuCl2 from moles of copper 2 chloride. Using my balanced chemical equation, I can go to moles of NaCl. And for moles of NaCl, I can go to grams of NaCl. Okay, so I'm starting with 20.0 grams of CuCl2. Got to get rid of grams and get moles, so I have to use my molar mass. So for every 1 mole of copper 2 chloride, I'm using 134.452 grams of copper 2 chloride. Okay, now let's look at our chemical equation because we've gotten to this step here, this to this. Now we have to use our mole ratio to convert from copper 2 chloride to sodium chloride. Well, I know there's a silent 1 here, and there's definitely a 2 here. So for every, I want to switch back to black. Here we go. For every 1 mole of CuCl2, I get 2 moles of NaCl. Okay, that's my mole ratio. So now I have moles of NaCl. That's awesome. Okay, so now I can go to grams of NaCl. For every 1 mole, OLE, of NaCl, I get 58.443 grams of NaCl. Let's put this fun thing into our calculator. 20.0 divided by 134.452. Nope, I did not put my point in there. 134.452. Okay, times 2 because this 2 moles of NaCl is on the top. Okay, then times 58.443. So that gets me 17.387, lots of other numbers. But knowing that I started with 3 sig figs, I have to round it to 3 sig figs. So I'm going to round it to 17.4 grams of sodium chloride. Okay, so what we did today in this video is we did gram, 2 gram stoichiometry, which is really honestly like the real good application of chemistry, because really you're always going to be limited by the amount of substances that you have. So you're like, all right, I've got this much, how much can I make? Okay, that's it for this video. So send us an email, either me or Mrs. Ellis, if you have any questions. We'd be glad to answer. Have a great day.